Now let's look at the operational use of high-resolution numeric models on severe convective weather, such as hail, convective windstorms, and heavy rain. Firstly, we talk about hail forecasting. The principles of hailstone forming involve complex cloud physics. Much of cloud microphysics would have to be summarized in order to inquire in detail into the mechanisms and the rates of hailstone and brew information. The two most direct routes to a 5 mm ice particle are the ice process and the freezing of a large raindrop formed by coalescence. In the ice process, typically a cloud droplet forms, freezes, grows into a snow crystal, starts collecting supercooled water droplets, and becomes a graupel that constitutes the hailstorm embryo. In order to gain the simplified goal, two aspects related to the important conditions for hailstone information are as follows. One is adequate updraft to keep the hailstorm aloft long enough. The updraft are influenced by dynamic effects such as vertical shear as well as by buoyancy. Another is supercooled water content to enable it to grow fast enough before falling out. The supercooled water content is partly influenced by the height of the wet bulb temperature zero. Low height bulb temperature zero also means that the likelihood of hail melting is reduced because the cloud to ground distance is short. So, in summary, high lapse rate, high vertical shear, and low height of the wet bulb temperature zero are favorable environment conditions for hail forecasting. Classification of storms into multi-cells and subcells organizations. Wind, shear, and buoyant instability has been explored. Look at this image. Hail forms in thunderstorms when strong vertical air motion allows frozen particles to grow by the accretion of supercooled liquid water. So the multi-cells and subcells organizations are related to hailstorm. So a systematic comprehensive analysis forecast processes include synoptic and mesoscale analysis to help us make the course expected weather. Then after checking the current conditions at the surface and aloft, and then comparing them to the model forecast initial conditions or the 0-hour forecasts, we decide that they are close enough to allow us to trust that the models are at least starting off well. The principles of hailstorm growth have been talked in the last slide. When using the high-resolution numeric model, the important aspects you should use are as follows. After mesoscale and sounding analysis of model forecast, we can check high lapse rate and vertical shear, adequate height of wet bulb temperature zero, hypothesize the organization of thunderstorm, make the comparison of model reflectivity with actual observations in nearby time, and check the profile of hydrometers, especially graupel from model.
下午3点左右，上海市东江区四金9平等地出现冰雹，小冰块犹如黄豆大小一起落下。1个多小时后，上海市中心区域天色逐渐变暗，从外滩眺望对岸，陆家嘴高楼逐渐被浓雾遮挡，随即大雨袭来，并翻涌一片。
This is the case in Shanghai on August 18, 2019. Hail, which was reported at Songjiang district of Shanghai, also with high convective wind and heavy rain. Firstly, let's look at the environment circulation. In the left, it is the synoptic chart in 500 millibar. The red box is represented for Shanghai. At 8 o'clock CST, the deep trough nearby is located in the west of Shanghai. Look at the right image. It is the synoptic chart in 700 millibar. The green figures represent for the temperature difference between 500 millibar and 700 millibar. The high temperature lapse rate in the red box is significant. In Shanghai, the high lapse rate are in the lower middle troposphere above. When the low-level moisture becomes higher, it will create the extreme convective available potential energy, later called CAPE values. The synoptic condition is favorable for the severe weather. Soundings measurement taken in Shanghai at 8 o'clock CST indicates CAPE of 2054 joule per kilogram. The surface to 6 km share is 11.3 meter per second, which is not very high in this moment. The height of the wet bulb temperature zero is 4.2 kilometers. Will it reduce in the future? So look at the right image, which is the vertical distribution of height meter in two different directions of the model forecasting at 14 o'clock CST. The 30 represent for the red direction. The 60 represent for the green line direction. The red triangle represent for the station of Xujiahui in Shanghai. Songjiang is located at the southwest of Xujiahui. The right image shows that the height of dry bulb temperature zero reduced afternoon, so we can see the height of the wet bulb temperature zero will reduce too in Songjiang. On the left, it is the sounding of Shanghai at 8 o'clock CST we talked about in the last slide. On the right, it is the max CAP and wind shear of the surface to the 6 km at 14 o'clock CST on August 18 at the initial time of 8 o'clock CST. The right image indicated that the wind shear intensified even greater than 20 meters per second in the red box, which let us expect that the organization of thunderstorm may be subsea, with the low height of the wet bulb zero expected. So the hail caused by subsea will fall in the afternoon in Shanghai. These are the model composite reflectivity forecasts at the initial time of 8 o'clock CST. In the left, it is at 12 o'clock. In the middle, it is at 13 o'clock. In the right, it is 14 o'clock. From these 3 hours model forecasts, similar bone echo or subcell embedded in the multi-cell initiate at the west of Shanghai. These are the model composite reflectivity forecast at the initial time of 8 o'clock. In the left, it is at 15. In the middle, it is at 16. In the right, it is at 17. From these 3 hours model forecast, similar bone echo embedded in the multi-cell past Shanghai. From the model composite reflectivity analysis, we conclude that the subcell embedded within multi-cell will maybe pass through Shanghai. The upper images are from satellite. The below images are from radar reflectivity. From the satellite and the real radar images from 11 o'clock to 7 o'clock CST, pay attention to this image at 15 o'clock. Here, the subcell causes hail in Songjiang. The up images are from real radar activities, and the below images are from model forecast. Compare the model forecast at 11 o'clock to 17 o'clock with real observation of radar at the same time. We decided that the organization mode from the models can be trusted, but the location and the intensity is not accurate. The subcell will pass from the west to the east, according to the model forecast. We can make hail and wind nowcasting, but we have no idea of where the hail will happen. Representing hail in models is a challenge, as the radon processes span from very small scales, for example, melting and sublimation on the surface of hailstorm, to large scale, for example, synoptic scale forcing for thunderstorm genesis. Most high models employ some type of microphysical parameterization to represent hail formation and maintenance processes. The microphysics schemes accounting for highest processes available in current operational weather forecast models group hail and grapple into the same hydrometeor category. For example, the microphysics schemes for Shanghai operational weather forecast model include ice, snow, and grapple hydrometeors. In the real ice processes, typically a cloud droplet forms, freezes, grows into a snow crystal, starts collecting supercooled water droplets, and become a grapple that constitutes the hailstone embryo. While ice process of global model cannot include grapple, so high-resolution model produced distribution of hydrometeor, especially grapple distribution, which is a useful product for hail forecasting. These complex cloud schemes forecast hydrometeor types that are not forecasted by models with simple schemes, including raindrop, grapple, and snow. The middle image shows us the hail fall in Songjiang, located in the southwest of Shijiahui, so we choose the vertical distribution of hydrometeor in the green line direction, where the hail reached the surface. Look at the right image in details. The light blue represents for grapple, the blue represents for ice, the green represents for snow, the yellow represents for cloud, and the red represents for rain. From this image, we see that the height of dry bulb zero calmed down, and so which indicates that the height of the wet bulb temperature zero will be proper, and the low bottom of grapple southwest of Shijiahui, which indicates maybe that the location of hail genesis. Look at vertical distribution of hydrometeors in the different direction. 1, 2, 3, 4, 5, 6 directions. Different numbers represent the different cross section. We found that the bottom of grapple in the lowest is 60 direction, where the hail happens there. So we can use these model products to strengthen your confidence of hail location forecasting. This is a Hebei case on June 25 this year, the very giant hail occurred at Baoding in Hebei province. Let's look at the picture, a very giant hail. The right circle in the left image shows the hail path. The right image shows the giant hail-like egg in Baoding. Let's look at the environmental circulation. The right image is the synoptic chart in 500 millibar. The shortwave trough is located in the west of Hebei. The right image is the synoptic chart in 700 millibar. The green figures represent for the temperature difference between 500 millibar and 700 millibar. From this red line, we see that in Hebei province, the temperature left red is significantly high. In high left red area in the low middle troposphere above, when the low level moisture becomes high, it will create the extreme CAPE values. So from the synoptic condition, we say it is favorable for the severe weather. Soundings measurement taken in Xingtai. Look at this image. Xingtai is here and she is near Baoding. At 8 o'clock CST, indicates CAP of 431.8 joule per kilogram. The surface to 6 kilometers here is 16.5 meter per second, which is very high. The height of wet bulb temperature zero is 3.1 kilometers, a very low height. We talked about before that it has a high left red this morning. So once the low level moisture becomes high, it will create the extreme CAPE values. So high wind shear and high expected CAPE let us expected the organization of thunderstorm may be subzero. Meanwhile, low height of wet bulb zero and dry middle level, the subzero will generate hail and heavy wind. Soundings measured taken in Beijing. Look at this image. Beijing is also near Baoding. At 8 o'clock CST, indicate CAP of 825.6 joule per kilogram. The level of wet bulb temperature zero is 3.4 kilometers. And the lapse rate is also high in Beijing. So the high lapse rate and the low height of wet bulb zero also give the forecast confidence to make hail forecast. From the model forecast at 16 o'clock CST, we see the wind in the 500 millibar straighten, which means the vertical shear will straighten greater than 20 meters per second, which lets us expect the organization of thunderstorm may be subzero. From Beijing RMAP 3 kilometer model forecast related with synoptic and mesoscale analysis of thunderstorm, hailstorm is the expected weather. Also from the 14 o'clock CST, we have awareness of subzero organization. When looking at sounding of Beijing at 14 o'clock CST, which is a real sounding, indicates CAP is greater than 1500 joule per kilogram. The level of wet bulb temperature zero is reduced, and the surface to 6 kilogram shear is growing to 18 meter per second. CAP and shear both straighten, which lets make sure the organization of thunderstorm may be subzero and the hail weather expected. Compare the model forecast at 15 o'clock CST with real observation of radar at the same time, we decided that they are close enough to allow us to trust the models. The soup seal will pass from the west to the east, according to the model forecast from 16 o'clock to 19 o'clock. We can make hail nowcasting, but we have no idea of what size of hail. We need additional information. What we need is observations. Look at these two polarization Doppler radar products. We use the identification of hail size. Look at this in the last line, giant hail or significant hail. The refractive is greater than 55 dBd and the ADI is equal to 0 or lower, and the CC is less than 0.9, and especially the KDP is not displayed. So we see this is at 14 o'clock in this day. So we see the KDP here, a very small area is not displayed, and so we can use these observations to identify the significant hair. In summary, firstly, a systematic comprehensive analysis forecast process includes synoptic and mesoscale analysis to help us have awareness on expected weather. Then, after checking the current conditions at the surface and aloft, and then compare them to the model forecast initial conditions of the 0-hour forecast, we decided that they are close enough to allow us to trust that the model are at least starting off well. The principle of hailstorms are as follows. Firstly, high lapse rate and high vertical wind shear and the low level of the wet bulb temperature zero. When using the high-resolution numeric model, the important aspects you should use are as follows. After mesoscale and sounding analysis of model forecast, we can also check high lapse rate and vertical wind shear, adequate height of wet bulb temperature zero, hypothesis the organization of thunderstorm, make the comparison of the model reflectivity with actual observations in nearby time, and check the profile of hydrometers, especially grapple.